It is given that x equals a cos square theta plus b sin square theta and x minus a into b minus x equals c square sin square theta cos square theta. We have to find the value of c. The options are a minus b, a plus b, a square minus b square and a square plus b square. So first we find the individual factors using this equation. So x equals a cos square theta plus b sin square theta. So multiplying a on both sides, we get x minus a equals a cos square theta minus a plus b sin square theta. We take a common in this term, so we get a cos square theta minus 1 plus b sin square theta and x minus a. That is, cos square theta minus 1 is minus sin square theta. So a minus sin square theta plus b sin square theta. Now in this we take sin square theta common, so we get sin square theta b minus a, and this is x minus a. Let this be equation 1. Similarly, minus x equals minus a cos square theta minus b sin square theta. We add b on both sides, we get b minus x minus a cos square theta plus b minus b sin square theta. That is minus a cos square theta minus b 1 plus b 1 minus sin square theta. That is minus a cos square theta plus b cos square theta. That is cos square theta b minus a. Let this be equation 2. Now we multiply equation 1 and 2 to get this LHS term. So we get x minus a into b minus x is sin square theta b minus a into b minus a cos square theta. That is equal to b minus a the whole square sin square theta cos square theta. This is x minus a b minus x. B minus a the whole square is equal to a minus b the whole square, and this is sin square theta cos square theta. But x minus a into b minus x is c square sin square theta cos square theta. So comparing the LHS and RHS, we can say c square equals a minus b the whole square. That is, c equals a minus b. So the correct answer is option A. So we need to find the value of cos 20 plus cos 100 plus cos 140. The options are cos 130, cos 45 and 0, or none of these. So let us rewrite the equation expression cos 20 plus cos 100 plus cos 140. That is cos 20 plus cos 140 plus cos 100. Now we apply the formula cos A plus cos B for these two terms. We get we apply the formula for these two terms. So we get cos 20 plus 2 cos 140 plus 100 by 2 into cos 140 minus 100 by 2. That is cos 20 plus 2 cos 120 into cos 20. Now cos 120 can be written as cos 20 plus 2 cos 90 plus 30 into cos 20. we take cos 20 common, so we get cos 20 1 plus 2 into cos 90 plus 30 is minus sin 30 degrees. So cos 20 degrees 1 minus sin 30 is half, so minus sin 30 is minus half, so 1 plus 2 into minus half. This is equal to cos 20 degrees 1 minus 1, that is equal to 0, which is option C. In this question we have to find the value of cos 55 plus cos 65 plus cos 175. The options are 0, 1, sin 18 and cos 36. So we can write this expression as in an alternative form: cos 90 minus 35 plus cos 90 minus 25 plus cos 180 minus 5. This can be also written as sin 35, since cos 90 minus theta is sin theta, plus sin 25, and this is cos 180 minus theta, so it remains cos, so it is cos but into minus cos 5. We use sin A plus sin B formula, so we get 2 into sin 30 into cos 5 minus cos 5. We take cos 5 common here, so we get 2 into sin 30 minus 1. Sin 30 is half, so cos 5 into 2 into 1 by 2 minus 1, that is cos 5 into 1 minus 1, that is equal to 0, which is option A. In this question we have to evaluate this expression: sin 10, sin 20, sin 40 and sin 50, and these are the options. So first we rearrange the term, so this is sin 10 plus sin 50 plus sin 40 plus sin 20, that is equal to, we use sin A plus sin B formula, so we get 2 sin 30 cos 20, and again here too we use sin A plus sin B formula, so that is 2 sin 30 cos 10. Sin 30 is half, so 2 into half to cos 20, plus again sin 30 is half, so 2 into half cos 10. This is equal to cos 20 plus cos 10. Now we apply cos A plus cos B rule, so we get, so this can be written in an alternative way as cos of 90 minus 70 plus cos 90 minus 80. 90 minus 80 is 10, 90 minus 70 is 20. So we get sin 70 plus sin 80, which is option number C. If tan of pi cos theta equals cot of pi sin theta, then what is the value of cos pi by 4 minus theta? The options are half, minus 1 by root 2, minus 1 by 2 root 2 or 1 by 2 root 2. So we write the equation: tan of pi cos theta equals cot of pi sin theta. Now cot theta is tan of pi by 2 minus theta, so we can rewrite this as tan of pi cos theta equals tan pi by 2 minus pi sin theta. So therefore we can write this: pi cos theta equals pi by 2 minus pi sin theta. We shift this term to the LHS, we get pi cos theta plus pi sin theta equals pi by 2. Divide throughout by pi, we get cos theta plus sin theta equals half. Now we divide throughout by 1 by root 2. Multiply throughout by 1 by root 2. So we get 1 by root 2 cos theta plus 1 by root 2 sin theta equals 1 by 2 root 2. Now 1 by root 2 is cos pi by 4 and 1 by root 2 is also sin pi by 4. So we can write this cos pi by 4 cos theta plus sin pi by 4 sin theta equals 1 by 2 root 2. So this is the formula for cos of pi by 4 minus theta, which is equal to 1 by 2 root 2. So we got the answer. So the answer is 1 by 2 root 2. If p equals cot 20, then we have to find the value of tan 160 minus tan 110 divided by 1 plus tan 160 into tan 110. And these are the options. So first, p equals cot 20 degree. That is, p equals 1 upon tan 20 degree. So we can say tan 20 degree is 1 by p. Now back to the main equation. We have tan 160 minus tan 110 upon 1 plus tan 160 into tan 110. This is the formula for tan 160 minus 110. This is equal to tan 50. Now tan 50 can be written as tan 90 minus 40. But tan 90 minus theta is cot theta. So we have tan 90 minus 40 is cot 40. Now cot 40 can be written as 1 upon tan 40. One upon 40 is 2 into 20. So we can write this 2 into 20. Now we expand it. So we get, using half angle formula, so we get 2 into tan 20 upon 1 minus tan square 20. But tan 20 is p. So we substitute the value 1 upon 2 into 1 by p upon 1 minus 1 by p the whole square. So we simplify this part and we get p square minus 1 by 2p, which is option A. In the question it is given that tan alpha plus cot alpha equals 2 sec 2 beta. So we have to find the value of alpha plus beta. The options are pi by 2, pi by 4, pi by 3 or none of these. So first we write the expression tan alpha plus cot alpha equals 2 sec 2 beta. Now we convert everything into sin and cos. So this is sin alpha upon cos alpha plus 1 upon cos alpha upon sin alpha equals 2 upon cos 2 beta. We cross multiply these terms. We get sin square alpha plus cos square alpha upon sin alpha cos alpha equals 2 upon cos 2 beta. Sin square alpha plus cos square alpha is 1. So we get 1 upon sin alpha cos alpha equals 2 upon cos 2 beta. We rearrange the terms. We get cos 2 beta equals 2 sin alpha cos alpha. 2 sin alpha cos alpha is sin 2 alpha. So cos 2 beta equals sin 2 alpha. This can be written as cos of pi by 2 minus 2 alpha. So from this we can say 2 beta equals pi by 2 minus 2 alpha. Therefore beta equals pi by 4 minus alpha. Therefore alpha plus beta equals pi by 4, which is option B. In the question, it is given that y is equal to 1 plus tan A into 1 minus tan B and A minus B equals pi by 4. We have to find the value of y plus 1 raised to y plus 1. The options are 9, 4, 27 and 81. So first we simplify this equation. 1 plus tan A into 1 minus tan B, that is 1 plus tan A minus tan B minus tan A into tan B. Let this be equation 1. Now A minus B equals pi by 4. So therefore tan of A minus B is tan pi by 4. Tan pi by 4 is 1. So this is equal to 1. Tan A minus B is tan A minus tan B upon 1 plus tan A tan B. We rearrange the terms, we get tan A minus tan B equals 1 plus tan A into tan B. We shift everything into LHS. We get tan A minus tan B minus tan A tan B equals 1. Add 1 on both sides, we get 1 plus tan A minus tan B minus tan A into tan B equals 1 plus 1. This whole term is y. So y equals 1 plus 1, that is y is equal to 2. So y plus 1 raised to y plus 1 is 2 plus 1 raised to 2 plus 1, that is 3 raised to 3, that is 27, which is option C. It is given that sec 2 theta equals p plus tan 2 theta. So we have to find the value of sin square theta, and these are the options. So first we have a formula which says sec theta plus tan theta equals 1 upon sec theta minus tan theta. So we are going to use this formula to get the answer. So sec 2 theta equals p plus tan 2 theta, that is sec 2 theta minus tan 2 theta equals p. So these are reciprocals, so it can be said that sec 2 theta plus tan 2 theta is 1 by p. Let this be equation 1. Let this be equation 2. So now we add these equations. We get 2 sec 2 theta equals p plus 1 by p. Now this can be written as 2 upon cos 2 theta equals p square plus 1 by p, that is 2p upon p square plus 1 is cos 2 theta. Now cos 2 theta is 1 minus 2 sin square theta, which is equal to 2p upon p square plus 1. We rearrange the terms, we get 2 sin square theta equals 1 minus 2p upon p square plus 1. This is equal to p square plus 1 minus 2p upon p square plus 1. This is the formula for p minus 1 the whole square. So this is p minus 1 the whole square upon p square plus 1. So this is 2 sin square theta. So sin square theta is half p square plus 1 into p minus 1 the whole square, which is option A. The question is, if 2 into sine raised to 6 theta plus cos raised to 6 theta plus 1 equals 3 into sine raised to n theta plus cos raised to n theta, then what is the value of n? The options are 4, 3, 2 and minus 1. So first we simplify the LHS. So we have 2 into sine raised to 6 theta plus cos raised to 6 theta. Sine raised to 6 theta can be written as sine square theta cube plus cos square theta cube. So sine square theta cube plus cos square theta cube plus 1. This is in the form of a cube plus b cube. So we can write this as 2 into sine square theta plus cos square theta cube minus 3 sine square theta cos square theta into sine square theta plus cos square theta plus 1. So this term is 0, this term is 0 because sine square theta plus cos square theta is 1. So 2 into 1 minus 3 sine square theta cos square theta plus 1. So this is 2 minus 6 sine square theta cos square theta plus 1. 2 plus 1 is 3. So we have 3 minus 6 sine square theta cos square theta. We take 3 common. So we have 1 minus 2 sine square theta cos square theta. But 1 is sine square theta plus cos square theta. So we have 3 into sine square theta plus cos square theta. We can write this as raised to 2 minus 2 sine square theta cos square theta. So this is in the form of a plus b the whole square minus 2ab. So this is the formula for a square plus b square. So we can write this as 3 into sine raised to sine square theta square plus cos square theta square. This is nothing but 3 into sine raised to 4 theta plus cos raised to 4 theta. So comparing this with RHS, we get n equals 4 and the answer is A. It is given that 1 plus 4p square equals 4p into sec theta. We have to find the value of sec theta plus tan theta. The options are plus or minus 2p, plus or minus 1 by 2p, 2p raised to plus or minus 1 or 2p plus or minus 1 by 2p. So we have 1 plus 4p square equals 4p into sec theta. So sec theta equals 1 plus 4p square upon 4p. So we got this term. Now we have to find tan theta. So tan square theta is sec square theta minus 1. So sec theta is 1 plus 4p square by 4p. So 1 plus 4p square by 4p the whole square minus 1. So this can be written as 1 plus 8p square plus 16p raised to 4 minus 16p square divided by 16p square. We simplify this, we get tan square theta equals 1 minus 4p square raised to 2 divided by 16p square. So that is tan theta equals plus or minus 1 minus 4p square upon 4p. So we have tan theta now. So adding 1 and 2, we get sec theta plus tan theta equals 1 plus 4p square by 4p plus or minus 1 minus 4p square upon 4p. Now consider case 1, we add it. So we get 1 plus 4p square by 4p plus 1 minus 4p square by 4p. So we get 1 upon 1 plus 1 upon 4p. So this turns out to be 1 upon 2p. This is case 1 when we add it. Now case 2 we subtract it. So it is 1 plus 4p square minus 1 plus 4p square upon 4p. So this is 4p square, 2 into 4p square upon 4p. So this is 2p. This is case 2 when we subtract it. So the possible answers are sec theta plus tan theta is either 1 by 2p or 2p. That is, we can say 2p raised to plus or minus 1, which is option C. It is given that R1 equals 4a cosec theta cot theta and R2 equals 4a sec theta tan theta. So we have to find the value of R1 raised to 4 by 3, R2 raised to 4 by 3 by R1 raised to 2 by 3 plus R2 raised to 2 by 3. So for this problem we will solve the numerator separately and the denominator separately. So firstly, R1 is 4a cosec theta cot theta, that is 4a, this is cos upon sine and this is 1 upon sine. So we can write this as cos theta upon sine square theta. Let this be equation 1. R2 equals 4a sec theta tan theta. Tan theta is sine upon cos theta and sec theta is 1 upon cos theta. So we can write this as sine theta, 4a sine theta upon cos square theta. Let this be equation 2. So first we find the numerator. This is R1 into R2 raised to 4 by 3. So we have 4a cos theta upon sine square theta into 4a sin theta upon cos square theta raised to 4 by 3. This is equal to 16a square upon sin theta cos theta raised to 4 by 3 and this also raised to 4 by 3. Let this be equation 3. And we solve the denominator too. So this is R1 raised to 2 by 3 plus R2 raised to 2 by 3. So we have 4a cos theta by sin square theta raised to 2 by 3 plus 4a sin theta upon cos square theta raised to 2 by 3. We take 4a common, so 4a raised to 2 by 3 cos raised to 2 by 3 theta upon sin raised to 4 by 3 theta plus sin raised to 2 by 3 theta upon cos raised to 4 by 3 theta. This is 16 raised to 2 by 3. Sorry, this is 16a square raised to 1 by 3. And this term can be simplified into cos square theta plus sin square theta upon sin raised to 4 by 3 theta into cos raised to 4 by 3 theta. Cos square theta plus sin square theta is 1. So we have 16a square raised to 1 by 3 into 1 by sin theta cos theta raised to 4 by 3. So we compare the numerator and the denominator. This term is the same. So numerator upon denominator is this gets cancelled out. So we are left with 16a square raised to 4 by 3 upon 16a square raised to 1 by 3. This is equal to 16a square 4 by 3 minus 1 by 3, which is 16a square 3 by 3. That is equal to 16a square, which is option B. It is given that cot theta into 1 plus sin theta equals 4m and cot theta into 1 minus sin theta is 4n. We have to find m square minus n square the whole square. The options are mn, 2mn, 3mn or 4mn. First we find 4m plus 4n. This is equal to cot theta minus, we expand this, so cot theta sin theta plus cot theta minus, this is plus, minus cot theta sin theta. So 4m plus 4n is 2 cot theta. Therefore 2 into m plus n is cot theta. Let this be equation 1. Similarly, we have 4m minus 4n equals cot theta plus cot theta sin theta minus cot theta plus cot theta sin theta. So that is 2 into 4 into m minus n is 2 cot theta sin theta. That is 2 into m minus n is cot theta sin theta. Let this be equation 2. Now we find 4m into 4n. This is equal to cot theta 1 plus sin theta into cot theta 1 minus sin theta. This is equal to cot square theta into 1 minus sin square theta, because this is in the form of a plus b, a minus b. So this is 16 mn. Let this be equation 3. So now we multiply equation 1 and 2. So we get 2 into m plus n into 2 into m minus n. From this we will be getting m square minus n square. So this is equal to cot theta into cos theta. So 4 into m square minus n square is equal to cot theta cos theta. Squaring both sides we get 16 m square minus n square the whole square equals cot square theta cos square theta. That is 16 m square minus n square the whole square equals cot square theta 1 minus sin square theta. So from equation 3 we can substitute the values 16 mn. So 16 m square minus n square the whole square equals 16 gets cancelled, so we are left with m square minus n square the whole square equals mn. So option A is the answer. So conditions are given: sin A equals P sin B and cos A equals Q cos B. We have to find the value of tan B. So these are the options. Now first, sin A equals P sin B. So first we divide these two equations. So we have sin A upon cos A equals Q cos B. This gives us tan A equals P by Q tan B. We found a relation between tan A and tan B. So let this be equation 1. Now we multiply these two equations. Sin A into cos A equals P into Q into sin B cos B. Sin A cos A is sin 2A by 2 and sin B cos B is sin 2B by 2. So sin 2A by 2 equals PQ sin 2B by 2. 2 gets cancelled, so we are left with sin 2A equals PQ sin 2B. But sin 2A is 2 tan A upon 1 plus tan square A. Similarly, for sin 2B, it is 2 tan B upon 1 plus, this is A, tan square B into PQ. Let this be equation 2. So we substitute 1 in 2. So we get P by Q tan B. We convert everything into tan B. So 1 plus P square by Q square tan square B equals PQ tan B upon 1 plus tan square B. Simplifying this equation, we get Q square plus P square tan square B equals 1 plus tan square B. We can also write this as, this is equal to, so we can also write this as Q square minus 1 equals 1 minus P square into tan square B. That is, tan B equals root of Q square minus 1 upon 1 minus P square, which is option C. If tan square theta equals 1 plus 2 tan square phi, then cos square phi is what? The options are 2 cos 2 theta, 1 plus 2 cos 2 theta, 1 minus cos 2 theta and 1 plus cos 2 theta. So let us rewrite the expression. Tan square theta equals 1 plus 2 tan square theta, tan square phi. We rearrange the terms. This is tan square theta minus 1 equals 2 tan square phi. That is 1 upon tan square phi is equal to 2 upon tan square theta minus 1. We have separated the phi and separated the theta. So by applying componendo dividendo rule, we get 1 minus tan square phi upon 1 plus tan square phi equals 2 minus tan square theta minus 1 upon 2 plus tan square theta minus 1. So this is the formula for cos 2 phi. So this is cos 2 phi, and this can be rearranged into 2 plus 1 minus tan square theta upon 1 plus tan square theta. So we split the numerator, and now we get 2 upon 1 plus tan square theta plus 1 minus tan square theta upon 1 plus tan square theta. 1 plus tan square theta is sec square theta. So we have cos 2 phi equals 2 upon sec square theta plus, this is the formula for cos 2 theta. So this is cos 2 theta. Sec square theta is 1 upon cos square theta. So we have 2 cos square theta plus cos 2 theta, which is cos 2 phi. 2 cos square theta is 1 plus cos 2 theta, and this remains the same. So the final expression is 1 plus 2 cos 2 theta, which is cos 2 phi, and there is a correction in the question. We are supposed to find cos 2 phi. So cos 2 phi is 1 plus 2 cos 2 theta, which is option B. So option B is the right answer. If cos 2 alpha is 3 cos 2 beta minus 1 upon 3 minus cos 2 beta, then and tan alpha equals k tan beta, then find k. The options are plus or minus 1, plus or minus root 2, plus or minus root 3, or plus or minus 2. So first we rewrite the equation to cos 2 alpha equals 3 cos 2 beta minus 1 upon 3 minus cos 2 beta. That is 1 upon cos 2 alpha equals 3 minus cos 2 beta upon 3 cos 2 beta minus 1. So now we apply componendo dividendo rule. We get 1 minus cos 2 alpha upon 1 plus cos 2 alpha equals 3 minus cos 2 beta minus 3 cos 2 beta minus 1 upon 3 minus cos 2 beta plus 3 cos 2 beta minus 1. Now this is 1 minus cos 2 alpha is 2 sin square alpha, and 1 plus cos 2 alpha is 2 cos square alpha. And this can be simplified into 4 minus 4 cos 2 beta upon 2 plus 2 cos 2 beta. Sin upon cos is tan. So this is tan square alpha is 2 into, taking 2 common, 1 minus cos 2 beta upon 1 plus cos 2 beta. So we do the same here too. So we get 2 into 2 sin square beta upon 2 cos square beta. That is 2 tan square beta, which is equal to tan square alpha. That is tan alpha equal to plus or minus root 2 tan beta. Now comparing this with the given data, tan alpha equals k into tan beta. So we can see k equals plus or minus root 2, which is option B. If cos of theta minus alpha, cos theta and cos of theta plus alpha are in HB, then cos theta sec alpha by 2 is equal to, the options are plus or minus root 2, plus or minus root 3, plus or minus 1 by root 2, and plus or minus 1 by root 3. Now these terms are in HP, so therefore the inverse will be in AP. So we can write 1 by cos theta minus alpha, 1 by cos theta, and 1 by cos theta plus alpha are in AP. So by the property of AP, 2 times the mean, that is cos theta, 1 upon cos theta is equal to sum of the extremes, that is 1 upon cos theta plus alpha plus 1 upon cos theta minus alpha. So rearranging the terms, we get 2 upon cos theta, we cross multiplied, so we get cos of theta minus alpha plus cos theta plus alpha upon cos of theta plus alpha into cos of theta minus alpha. We can rewrite this as 2 upon cos theta, 2 into cos of theta into cos alpha, and cos square theta minus sin square alpha. Therefore 2 gets cancelled here, so we are left with 2 cos square theta minus sin square alpha equals cos square theta cos alpha. So that is cos square theta minus cos square theta cos alpha equals sin square alpha. We take cos square theta common, so we get 1 minus cos alpha is equal to sin square alpha. Now 1 minus cos alpha can be written as 2 sin square alpha by 2. So this is cos square theta 2 into sin square alpha by 2 equals, now sin square alpha can be written as into half, it can be written into half angle form. So we get 4 times sin square alpha by 2 cos square alpha by 2. So sin square alpha by 2 gets cancelled, 2 gets cancelled, so we are left with cos square theta equals 2 into cos square alpha by 2, that is cos square theta into sec square alpha by 2 equals 2. Taking roots on both sides, we get cos theta sec alpha by 2 is plus or minus root 2, which is option A. So the question is, if sec alpha and cosec alpha are the roots of x square minus px plus q equals 0, then we have to determine the relation between p and q. So these are the options. So now p is the coefficient of x. So since sec alpha and cosec alpha are the roots of the equation, we can say that p is the sum of the roots, that is sec alpha plus cosec alpha, and the term q is the product of the roots, that is sec alpha into cosec alpha. We can simplify it further. So p equals sec alpha is 1 upon cos alpha and cosec alpha is 1 upon sin alpha. We cross multiply it and we get sin alpha plus cos alpha upon sin alpha cos alpha. Similarly for q, we get 1 upon sin alpha into cos alpha. Now when we divide p by q, we get, since the denominators are same, they get cancelled. So what is left is sin alpha plus cos alpha. Now we square both the sides, so we get p by q the whole square is sin alpha plus cos alpha the whole square. Expanding the brackets, we get p square by q square equals sin square alpha plus cos square alpha plus 2 sin alpha cos alpha. Sin square alpha plus cos square alpha is 1 and p square plus q square. This is 1 by q because q is the product of reciprocals of sin alpha and cos alpha. So this is 2 by q. Now multiplying throughout by q square, we get p square equals q square plus 2q square by q, that is p square equals q square plus 2q, that is p square equals, taking q common, q into q plus 2, which is option B. It is given that sin alpha plus beta is 1 and sin alpha minus beta is half. We have to find the value of tan alpha plus 2 beta into tan 2 alpha plus beta. The options are -1, 0, 1 and 2. So first sin alpha plus beta is 1, but 1 is equal to sin pi by 2 radians. So therefore we can say alpha plus beta is pi by 2. Let this be equation 1. Second, sin alpha minus beta is half, which is sin pi by 6. So therefore alpha minus beta is pi by 6. Let this be equation 2. So solving this equation simultaneously, we get alpha equals pi by 3 and beta equals pi by 6. So we substitute the values in this expression. We get tan of pi by 3 plus 2 into pi by 6 into tan of 2 pi by 3 plus pi by 6, that is tan of 2 pi by 3 into tan of 5 pi by 6. Now this can be written as tan of pi minus pi by 3 into tan of pi minus pi by 6. Now tan of pi minus theta is minus pi, tan of pi minus theta is minus tan theta. So we have minus tan pi by 3 into minus tan pi by 6. So minus into minus is plus. So we get tan pi by 6, tan pi by 3 is root 3 and tan pi by 6 is 1 by root 3. So root 3 divided by root 3 is 1, which is option C. Question is, if sin A is A cos B and cos A is B sin B, then A square minus 1 into tan square A plus 1 minus B square, 1 minus B the whole square, tan square B is what? These are the options. So first we consider the equations. Sin A is A cos B and cos A is B sin B. We square it and add it. So we get sin square A plus cos square A is A square cos square B plus B square sin square B. So sin square A plus cos square A is 1. A square plus cos square B plus B square plus sin square B. We rearrange the terms. We get sin square B as A square minus 1 upon A square minus B square. Similarly, we get cos square B is 1 minus B square upon A square minus B square. So therefore, tan square B is sin square B upon cos square B, that is A square minus 1 upon 1 minus B square. So now we divide 1 and 2. So sin A by cos A is equal to A by B cos B by sin B. So tan A is A by B into 1 upon tan B. That is, so tan A is A by B into 1 by tan B. Squaring both sides, we get tan square A equals A square by B square upon 1 by tan square B. We substitute the value of tan square B, we get tan square A equals A square by B square into 1 upon A square minus 1 upon 1 minus B square. So therefore, tan square A is A square upon B square into 1 minus B square upon A square minus 1. Let this be equation 3. Let this be equation 4. Now we substitute those values in the final expression. So the final expression is A square minus 1 tan square A plus 1 minus B square tan square B. Tan square A is A square upon B square 1 minus B square upon A square minus 1, and tan square B is A square minus 1 upon 1 minus B square. So substituting these values, we get A square minus 1 into A square upon B square into 1 minus B square upon A square minus 1 plus 1 minus B square into A square minus 1 upon 1 minus B square. So 1 minus B square gets cancelled, A square minus 1 gets cancelled. We are left with A square by B square into 1 minus B square plus A square minus 1. Simplifying this whole term, we finally get A square minus B square upon b square, which is option A. So the answer here is a square minus b square by b square. If cos of theta minus alpha, cos theta and cos of theta plus alpha are in HP, that is harmonic progression, then which of the following is true? So these are the options. So first we'll convert this harmonic progression into arithmetic progression. So HP is inverse of AP. So we can write this as cos theta minus alpha 1 upon cos theta and 1 upon cos theta plus alpha are in AP. So now by the property of AP, 2 times the middle term, that is cos theta 1 upon cos theta, is sum of cos of 1 upon cos of theta minus alpha plus 1 upon cos of theta plus alpha, that is the sum of extreme terms. This can be simplified as 2 upon cos theta equals, we cross multiplied, so we get cos theta plus alpha plus cos theta minus alpha upon cos theta minus alpha into cos theta plus alpha, that is 2 upon cos theta. This is in the form of cos A plus cos B, so we can simplify it as cos 2 into cos theta into cos alpha divided by cos of theta minus alpha into cos of theta plus alpha. Also this term can be written as 2 by cos theta to 2 cos theta cos alpha upon cos square theta minus sin square alpha. Rearranging terms, we get 2 times 2 gets cancelled, so cos square theta minus sin square alpha equals cos square theta cos alpha, that is cos square theta minus cos square theta into cos alpha minus sin square alpha. Alpha is 0, that is 1 minus cos alpha cos square theta is sin square alpha. 1 minus cos alpha is 2 sin square alpha by 2 into cos square theta equals sin square alpha can be written as 2 into sin alpha by 2 into cos alpha by 2 the whole square, that is 2 sin square alpha by 2 cos square theta equals 4 times sin square alpha by 2 cos square alpha by 2. Sin square alpha by 2 gets cancelled and 2 gets cancelled, so we are left with cos square theta is 2 cos square alpha by 2. Okay, so we take root of this equation, so we get cos theta equals root 2 cos alpha by 2, which is option B, cos theta equals root 2 cos alpha by 2. So it is given that tan alpha by 2 and tan beta by 2 are the roots of the quadratic equation 8x square minus 26x plus 15 equals 0. We are supposed to find the value of cos alpha plus beta, and these are the options. So first we will simplify the quadratic equation. So 8x square minus 26x plus 15 equals 0. Dividing throughout by 8, we get x square minus 26 by 8 plus 15 by 8 equals 0. So now the coefficient of x is the sum of the roots, and the term 15 by 8 is the product of the roots. So we can write tan alpha by 2 plus tan beta by 2 is 26 by 8, that is 13 by 4, and tan alpha by 2 into tan beta by 2 is 15 by 8. Let this be 1, let this be 2. Now tan alpha plus beta by 2 is given by tan alpha by 2 plus tan beta by 2 divided by 1 minus tan alpha by 2 into tan beta by 2. We have the value for this here, so it is 13 by 4 upon 1 minus 15 by 8. Simplifying this, we get tan alpha plus beta by 2 is equal to minus 26 by 7. Now cos of alpha plus beta in terms of half angle form of tan is 1 minus tan square alpha plus beta by 2 upon 1 plus tan square alpha plus beta by 2. So we substitute the value here, so we get 1 minus 26 upon 7 square upon 1 plus minus 26 upon 7 square. Solving this, we get minus 627 upon 725, which is option A. If sin square theta plus 3 cos theta minus 2 is 0, then what is the value of cos cube theta plus sec cube theta? The options are 18, 9, 4 and 1 by 4. So let us simplify the equation. Sin square theta plus 3 cos theta minus 2 is 0. Sin square theta can be written as 1 minus cos square theta plus 3 cos theta minus 2 equals 0. So this is cos square theta plus 3 cos theta minus 1 equals 0. So that is cos square theta plus 1 is 3 cos theta. So dividing throughout by cos theta, we get cos theta plus 1 by cos theta is 3. 1 by cos theta is sec theta. So cos theta plus sec theta is 3. Let this be equation 1. Now we cube both sides. So cos theta plus sec theta, the whole cube is 3 cube. That is cos cube theta plus sec cube theta plus 3 into cos theta sec theta into cos theta plus sec theta equals 27. Now cos theta into sec theta, this term is 1 because they are reciprocals. So cos cube theta plus sec cube theta plus 3 into cos theta plus sec theta is 27. Now cos theta plus sec theta is 3 from equation 1. So this is cos cube theta plus sec cube theta plus 3 into 3 equals 27. So cos cube theta plus sec cube theta plus 9 equals 27. So cos cube theta plus sec cube theta is 18, which is option number A. Sin theta plus tan theta is m and tan theta minus sin theta is n. Then what is m square minus n square? We have to find this in terms of m and n. So first equation is tan theta plus sin theta equals m. Let this be equation 1. And tan theta minus sin theta is n. Let this be equation 2. Now adding these equations, we get m plus n equals 2 tan theta, and subtracting we get m minus n equals 2 sin theta. Now we are supposed to find m square minus n square. So m square minus n square is m plus n, m minus n. So we substitute the values, that is 2 tan theta into 2 sin theta, that is 4 tan theta sin theta. Let this be equation number 3. Because we are supposed to find this in terms of m and n, we are supposed to modify this. We are supposed to convert this. So we consider mn. So we multiply the terms m and n, we get sin theta plus tan theta into tan theta minus sin theta. This is in the form of a plus b, a minus b. So we get tan square theta minus sin square theta. Taking sin square theta common, we get sin square theta 1 upon cos square theta minus 1. We cross multiply. So sin square theta 1 minus cos square theta upon cos square theta. Sin square theta upon cos square theta is tan square theta, and 1 minus cos square theta is sin square theta, mn. So mn is tan theta sin theta the whole square. So therefore tan theta into sin theta is root of m into n. So let this be equation number 4. So we substitute 4 in equation 3. We get m square minus n square equals 4 into tan theta into sin theta. So that is root of mn, which is option 4. So we have to simplify sin a minus b upon cos a cos b plus sin b minus c upon cos b cos c plus sin c minus a upon cos c cos a. The options are 0, sin of a minus b minus c, tan of a minus b minus c, and none of these. So we simplify it individually. So first we consider this sin a minus b upon cos of a cos b. Now sin a minus b is sin a cos b minus cos a sin b upon cos a cos b. This is when we split the term, we get sin a upon cos a minus sin b upon cos b, that is tan a minus tan b. Let this be 1. Similarly sin b minus c upon cos b into cos c equals sin b cos c minus cos b sin c divided by cos b cos c. That is, now we split the term, we get sin b upon cos b equals sin c upon cos c, that is tan b minus tan c. Let this be 2. Similarly for third one, sin c minus a upon cos c cos a, that is sin c cos A minus cos C sin A upon cos C cos A. Again we split the term, we get sin C upon cos C minus sin A upon cos A, that is tan C minus tan A. This is 3. Now we are supposed to add 1, 2 and 3. So we get tan A minus tan B plus tan B minus tan C plus tan C minus tan A. So everything gets cancelled and we are left with 0. So the answer is A, 0. It is given that 3 tan theta into tan phi is 1. So we are supposed to find the value of cos of theta minus phi upon cos theta plus phi. The options are 1, 2, 3 and 4. So consider this equation, tan theta tan phi equals 1. Now we convert everything into sin and cos. So this is 3 sin theta upon cos theta into sin phi upon cos phi equals 1. That is cos theta cos phi upon sin theta sin phi is 3 by 1. Now we apply componendo dividendo rule. So we get cos theta cos phi plus sin theta sin phi upon cos theta cos phi minus sin theta sin phi. We did this so that we could form a trigonometric function of theta plus or minus phi. So this is 3 plus 1 upon 3 minus 1. So this is in the form of cos A cos B plus sin A sin B. So this is a formula of cos of theta minus phi. Similarly, this is cos of theta plus phi, and this is 4 by 2. So cos of theta minus phi by cos of theta plus phi is 2, which is option B. If tan x equals to b by a, then root of a plus b by a minus b plus root of a minus b upon a plus b is what? The options are 2 sin x upon root sin 2x, b 2 cos x upon root cos 2x, c 2 cos x upon root sin 2x, d 2 sin x upon root cos 2x. So first tan x is b by a. So we first simplify this form, root of a minus b upon a plus b. So we divide throughout by a. So we get 1 plus b by a upon 1 minus b by a plus root of 1 minus b by a upon 1 plus b by a. That is equal to, we cross multiply it now, so we get root of 1 plus b by a the whole square plus root of 1 minus b by a the whole square upon root of 1 minus b by a 1 plus b by a. So this is 1 plus b by a plus 1 minus b by a upon root of a square. This is in the form of a plus b a minus b. So this is a square minus b square, that is 1 minus b square upon a square. This term gets cancelled, so we are left with 2 upon root of 1 minus b square upon a square. Rearranging the terms and substituting b by a is equal to tan x, we get 2 upon root of 1 minus tan square x. tan x is sin upon cos, sin x upon cos x. So this is root of 1 minus sin square x upon cos square x. That is 2 upon root of 1 minus sin square x upon cos square x. We cross multiplied, so cos square x minus sin square x upon cos square x, that is 2 cos x upon, now cos square x minus sin square x is cos 2x, so this is root of cos 2x, which is option B. Root 3 cosec 20 minus sec 20 equals what? The options are 1, 2, 3 and 4. So we rewrite the expression root 3 cosec 20 degrees minus sec 20 degrees. This can be written as in terms of sin and cos. Root 3 upon sin 20 minus 1 upon cos 20. Now we divide and multiply by 2. So we get 2 into root 3 by 2 upon sin 20 minus 1 by 2 cos 20. We are doing this so that we can get something in terms of sin and cos. So since root 3 by 2 and 1 by 2 is sine of 60 and cos of 60 respectively, we can get another trigonometric function. So sin 60 by sin 20 minus cos 60 upon cos 20. So now we cross multiply, we get 2 into sin 60 cos 20 minus cos 60 sin 20 divided by the denominator sin 20 cos 20. Now this is in the form of sin A cos B minus cos A sin B. This is the formula for sin of A minus B, that is sin of 60 minus 20, and the denominator remains the same, sin 20 cos 20. Now sin of 60 minus 20 is sin 40 divided by sin 20 cos 20. Now we can write sin 40 like this, 2 sin 20 cos 20 in terms of half angles. Similarly, so sin 20 cos 20. So these two terms are same, so they get cancelled out, and what is left is 2 into 2, which is 4. So D is the answer. We have to find the value of cos square pi by 8 plus cos square 3 pi by 8 plus cos square 5 pi by 8 plus cos square sin pi by 8. The options are 1, 2, 3 and 4. We can write it in this way. So 3 pi by 8 is pi by 2 minus pi by 8, and 5 pi by 8 is pi by 2 plus pi by 8, and sin pi by 8 can be written as pi minus pi by 8. We are doing this so that we get each and every trigonometric terms in terms of pi by 8. So first term remains the same, cos square pi by 8. Cos square of pi by 2 minus pi by 8 is sin square pi by 8, since cos of pi by 2 minus theta is sin theta. So sin square pi by 8 plus cos of pi by 2 plus theta is again sin theta. So sin square pi by 8 plus cos of pi minus theta is cos theta. So cos square pi by 8. Now we add them up. So this is 2 cos square pi by 8 plus 2 sin square pi by 8 we take this common, so we get cos square pi by 8 plus sin square pi by 8. This is in the form of sin square theta plus cos square theta, so which is 1. So we get 2 into 1, which is 2. So the answer is B, 2. We need to find the value of cos 40 plus cos 80 plus cos 160 plus cos 240. The options are minus 2, minus half, minus root 3 and minus 1 by root 3. So we simplify this expression. So this is cos 40, cos 80. We can write cos 60 as cos of 180 minus 60. And cos 240 as, this is cos 180 minus 20. And this is cos 180 plus 60. So this remains the same, cos 40 plus cos 80. Cos 180 minus theta is minus cos of 20. Similarly, cos 180 plus theta is minus cos of theta, that is minus into cos of 60. That is cos of 40 plus cos 80 minus cos 20 minus cos 60. Now we use cos A plus cos B rule. So we get 2 cos 60 into cos 20 minus cos 20 minus cos 60 is half. Similarly, we substitute half here. So 2 into half into cos 20 minus cos 20 minus half. So this is 2 gets cancelled, cos 20 minus cos 20 minus half. So this gets cancelled, so we are left with minus half, which is option B. It is given that 3 sin alpha is equal to 5 sin beta. We are supposed to find the value of tan alpha plus beta by 2 divided by tan alpha minus beta by 2. The options are 1, 2, 3 and 4. So first we take this equation, 3 sin alpha equals 5 sin beta. That is sin alpha upon sin beta is equal to 5 by 3. Now by using componendo and dividendo rule, we get sin alpha plus sin beta upon sin alpha minus sin beta. Similarly, 5 plus 3 by 5 minus 3. Now we use sin A plus sin B formula and sin A minus sin B formula respectively. So we get 2 sin alpha plus beta by 2 cos alpha minus beta by 2 divided by 2 cos alpha plus beta by 2 sin alpha minus beta by 2, and here we get 8 by 2. So here we get sin 2 gets cancelled, so sin alpha plus beta by 2 divided by cos alpha plus beta by 2 into cos alpha minus beta by 2 upon sin alpha minus beta by 2 is equal to 4. This is tan alpha plus beta by 2 divided by, this is inverse of tan, so tan of alpha minus beta by 2 is equal to 4, which is option D. Question is, we have to find the value of cos square theta plus cos square 120 plus theta plus cos square 120 minus theta. The options are 2 by 3, 3 by 2, 4 by 5 and 5 by 4. So first we consider this term and we simplify it. So cos square 120 plus theta plus cos square 120 minus theta. Now cos square x is half into 1 plus cos 2 theta. So we apply this formula to both of these terms. So this is half into 1 plus cos of 2 times 120 plus theta plus half into 1 plus cos 2 times 120 minus theta. Taking half common, we get 1 plus cos 240 plus 2 theta plus 1 plus cos 240 minus 2 theta. So half of 1 plus 1 plus half of cos 240 plus 2 theta plus cos 240 minus 2 theta. Half of 1 plus 1 is 1. So plus half. Now this is in the form of cos A plus cos B. So we can simplify it as cos of 240 into cos 2 theta. Now 1 plus half 2 into. Now we can write this as cos of 270 minus 30 into cos 2 theta. 1 plus half 2 into. Now cos of 270 minus theta is minus of sin theta. So in this case it is minus sin 30 degrees into cos 2 theta. Which is equal to 1 plus half 2 into minus half cos 2 theta. That is 1 plus half. This gets cancelled. So we are left with cos 2 theta. That is 1 minus half cos 2 theta. Now this is the second half of the expression. So we add cos square theta to it, and cos square theta is 1 half into 1 plus cos 2 theta. This is cos square theta plus 1 minus half into cos 2 theta. Now we expand this, we get half plus half into cos 2 theta plus 1 minus half into cos 2 theta. So this term gets cancelled. So we are left with 1 plus half, which is 3 by 2, and this is option B. We have to find the value of root 3 cot 20 minus 4 cos 20. The options are 1, root 2, root 3 and none of these. So first we rewrite the expression. So root 3 cot 20 minus 4 cos 20. Cot 20 is cos 20 upon sin 20. So root 3 cos 20 upon sin 20 minus 4 cos 20. We cross multiplied, so we get root 3 cos 20 minus 4 cos 20 sin 20 divided by sin 20. Now we multiply and divide to this numerator, this part of numerator. So we get 2 into root 3 by 2 into cos 20 minus, and we split the number 4 into 2 into 2. So 2 into 2 times cos 20 sin 20 divided by sin 20. So root 3 by 2 is sin 60. So we get 2 times sin 60 into cos 20 minus 2 times cos 20 sin 20 is sin 40. So this is sin 40 divided by sin 20. Now this can be written as 2 times, we can convert 2 times sin 60 into cos 20 in the form of sin A plus sin B. So this is 2 times sin 60 plus 20, that is 80, plus, there's no 2 here, so sin of 60 plus 80 plus sin of 60 minus 20, 60 plus 20 and 60 minus 20, that is 40, minus 2 times sin 40 divided by sin 20. This is equal to sin 80 minus sin 40 divided by sin 20. Again we use the formula sin A minus sin B. So this is 2 times cos 80 plus 40 by 2, that is 60, into sin of 80 minus 40 divided by 2, so that is 20, divided by sin 20. So sin 20 gets cancelled, so we are left with 2 times cos 60. Now cos 60 is half, so 2 into half, this is equal to 1, and the answer is option A, 1. Pn is cos raised to n theta plus sin raised to n theta. Then 2 times p of 6 minus 3 times p of 4 is what? The options are minus 1, 0, 1 and none of these. So p of 6 is cos raised to 6 theta plus sin raised to 6 theta. Similarly, p4 is cos raised to 4 theta plus sin raised to 4 theta. Therefore 2p6 minus 3p4 is 2 times cos raised to 6 theta plus sin raised to 6 theta minus 3 times cos raised to 4 theta plus sin raised to 4 theta. This can be written as 2 into cos square theta cube plus sin square theta cube, and this can be written as cos square theta square plus sin square theta square. So now this is 2 into cos square theta plus sin square theta the whole cube minus 3 times cos square theta sin square theta into cos square theta plus sin square theta. This is the first term, this one, minus 3 into cos square theta a square plus b square. So this is a plus b the whole square minus 2ab. So this is cos square theta plus sin square theta the whole square minus 2 times cos square theta sin square theta. So this is 1, this is 1, this is 1. So we can simplify it as 2 into 1 minus 3 cos square theta sin square theta minus 3 into 1 minus 2 cos square theta sin square theta. Further expanding, we get 2 minus 6 sin square theta into cos square theta minus 3 plus 6 sin square theta into cos square theta. This term gets cancelled. We are left with 2 minus 3, 3, which is minus 1, and the answer is option 1, minus 1. In this question we are supposed to evaluate this expression sin of 163 into cos 347 plus sin 73 into sin 167. The options are root 2, 1 by 2, root 3 and 1 by 3. So first we simplify each and every trigonometric term. So 163, sin of 163 can be written as sin of 180 minus 17, that is equal to sin 17. cos of 347 can be written as cos of 360 minus 13, that is equivalent to cos 13. Sin 73 is sin of 90 minus 17. Sin 90 minus theta is cos theta, so this is cos 17. And sin 167 is sin of 180 minus 13, that is equivalent to sin 13. So we substitute the values here. So we get sin 17 cos 13 plus cos 17 sin 13. So this is in the form of sin A cos B plus cos A sin B, and it is the formula for sin of A plus B. So in this case it is sin of 17 plus 13, that is sin of 30, which is equal to half. So the answer is B, 1 by 2. In this question we have to evaluate the expression cos raised to 4 pi by 8 plus cos raised to 4 3 pi by 8 plus cos raised to 4 5 pi by 8 plus cos raised to 4 7 pi by 8. The options are 1, half, 3 by 2 and 2. So firstly we know that cos pi minus theta is minus cos theta. So raising fourth power on both sides, we get cos raised to 4 pi minus theta is equal to cos raised to 4 theta. So we apply the concept to each and every term. So we get cos raised to 4 7 pi by 8 is equal to 7 pi by 8 can be written as cos raised to 4 pi minus pi by 8. Now cos of pi minus cos raised to 4 pi minus pi by 8 is equivalent to cos raised to 4 pi by 8. Let this be equation 1. Similarly, we can write cos raised to 4 5 pi by 8 is equal to cos raised to 4 5 pi by 8 can be written as pi minus 3 pi by 8. So cos raised to 4 pi minus 3 pi by 8 is the same as cos raised to 4 3 pi by 8. However, we can write cos raised to 4 3 pi by 8 as cos raised to 4 pi by 2 minus pi by 8. So cos of pi by 2 minus theta is sin theta. So this is sin raised to 4 pi by 8. So therefore cos raised to 4 5 pi by 8 is equal to cos raised to 4 3 pi by 8 is equal to sin raised to 4 pi by 8. Let this be equation 2. So now we substitute these values into the main expression. So we get cos raised to 4 pi by 8 plus cos raised to 4 pi by 8 plus sin raised to 4 pi by 8 plus sin raised to 4 pi by 8. Simplifying this, we get 2 times cos raised to 4 pi by 8 plus sin raised to 4 pi by 8. We can write this as 2 times cos square pi by 8 square plus sin square pi by 8 square. This is in the form of a square plus b square. This can be written as a plus b the whole square minus 2ab. So this is 2 times cos square pi by 8 plus sin square pi by 8 the whole square minus 2 times sin square pi by 8 into cos square pi by 8. Now cos square pi by 8 plus sin square pi by 8 is 1. So this is 2 times 1 minus 2 into sin square pi by 8 into cos square pi by 8. Now in this term we divide and multiply by 2. So we get 2 times 1 minus half into 4 sin square pi by 8 into cos square pi by 8. That is 2 times 1 minus half into 2 sin pi by 8 cos pi by 8 the whole square. I will rewrite the equation. So that is 2 into 1 minus half into 2 sin pi by 8 into cos pi by 8 the whole square. This is nothing but 2 sin theta cos theta, that is sin 2 theta. So this is 2 into 1 minus half into sin pi by 4 the whole square, that is 2 into 1 minus half into sin square pi by 4. Now sin pi by 4 is 1 by root 2. So this is 1 minus half into 1 by root 2 square, that is 2 into 1 minus half into half, that is 2 into 1 minus 1 by 4, that is 2 into 3 by 4, which is equal to 3 by 2, which is option C. We have to find the value of cos 1 upon cos 290 plus 1 by root 3 sin 250. So the options are A 1 by root 2, B 3 by root 2, C 4 by root 3, D none of these. So first we simplify these complex trigonometric functions. So first cos 290, it can be written as cos 270 plus 20 degree, which is equivalent to sin 20 degree. Similarly, sin 250 is sin 270 minus 20 degree, which is equivalent to minus cos 20 degree. So we substitute this in the main expression. So we get 1 upon sin 20 minus 1 by root 3 cos 20. So we cross multiply, so we get root 3 cos 20 minus sin 20 upon root 3 sin 20 cos 20. Now we multiply and divide by 2. So we get 2 into root 3 by 2 cos 20 minus half into sin 20. Similarly, root 3 by 2 times sin 20 into cos 20. We multiplied and divided by 2 in the numerator as well as the denominator. So now root 3 by 2 is sin 60 and half is cos 60. So we can rewrite this as 4 by root 3 into sin 60 cos 20 4 by root 3 sin 60 cos 20 minus cos 60 sin 20 divided by sin of 2 into 20, because this is 2 sin 20 cos 20, which is equivalent to sin of 2 times 20. This is 4 by root 3. Now this is the formula for sin A cos B minus cos A sin B, that is sin of A minus B. So here it is sin of 60 minus 20, and in the denominator it will be sin 40. So 4 by root 3, 60 minus 20 is 40, so sin 40 divided by sin 40. So these terms get cancelled, so we are left with 4 by root 3, which is option C. So the answer is C, 4 by root 3. If tan of pi cos theta is equal to cot of pi sin theta, then find cos of pi by 4 minus theta. The options are half, 1 by root 2, 1 by 2 root 2 and root 2 by 2. So first we consider the equation tan of pi cos theta equals cot of pi sin theta. Now cot theta is tan of pi by 2 minus theta. So this can be written as pi cos theta equals tan of pi by 2 minus pi sin theta. Since the tans are equal, the angles are equal. So pi cos theta is equal to pi by 2 minus pi sin theta. Dividing throughout by pi, we get cos theta equals 1 by 2 minus sin theta. That is equal to cos theta plus sin theta equals half. Now we divide throughout by root 2. So we get 1 by root 2 cos theta plus 1 by root 2 sin theta equals 1 by 2 root 2. Now this can be written as cos pi by 4 cos theta plus this can be written as sin pi by 4 into sin theta, which is equal to 1 by 2 root 2. So this is in the form of cos A cos B plus sin A sin B, which is the formula for cos of A minus B. So this is cos of pi by 4 minus theta, which is required, is equal to 1 by 2 root 2. So cos of pi by 4 minus theta is 1 by 2 root 2, which is option C. It is given that tan square theta is equal to 1 plus 2 tan square phi. So we have to find 1 plus 2 cos 2 theta in terms of trigonometric functions of phi. So the options are sin 2 phi, cos 2 phi, tan 2 phi, or none of these. So first we write the equation tan square theta equals 1 plus 2 tan square phi. That is 1 upon tan square theta is equal to 1 upon 1 plus 2 tan square phi. By using componendo dividendo rule, 1 minus tan square theta upon 1 plus tan square theta is equal to 1 minus 1 plus 2 tan square theta tan square phi upon 1 plus 2 tan square phi. This is the formula for cos 2 theta. So cos 2 theta is minus tan square phi divided by 1 plus tan square phi. So we got this term. So we modify the equation accordingly. So 1 plus 2 times cos 2 theta is 1 plus 2 times minus tan square phi upon 1 plus tan square phi. That is 1 minus 2 tan square phi upon 1 plus tan square phi. Cross multiplying, we get 1 plus tan square phi minus 2 tan square phi upon 1 plus tan square phi. That is 1 minus tan square phi upon 1 plus tan square phi. This is the formula for cos 2 phi. So this is equal to cos 2 phi. Therefore 1 plus 2 cos 2 theta is cos 2 phi. The answer is D. We have to simplify this. Sin square A minus sin square B upon sin A cos A minus sin B cos B. So we simplify the numerator separately and the denominator separately. So first the numerator. This is sin square A minus sin square B. This can be written as sin of A plus B into sin of A minus B. Whereas the denominator is sin A cos A minus sin B cos B. Now we divide and multiply by 2. So we get half into 2 times sin A cos A minus 2 times sin B cos B. Now this is in the form of 2 sin theta cos theta, which is sin 2 theta. So this gives half into sin 2A minus sin 2B. So now we apply the formula sin A minus sin B. So this gives us half into 2 times cos of A plus B into sin of A minus B. That is, denominator is 2 gets cancelled here. So cos of A plus B into sin of A minus B. So we substitute the values here. So the answer is sin A plus B into sin A minus B upon cos A plus B into sin A minus B. So this gets cancelled. So we are left with tan of A plus B, which is option C, tan A plus B. In this question we have to evaluate the expression tan 20 plus tan 40 plus root 3 tan 20 into tan 40. The options are 1, root 2, root 3 and none of these. So judging from the question, we will try a reverse approach. In the question there is a tan 20, a tan 40 and root 3, which is tan 60. So we start off with 20 plus 40 is 60. So tan of 20 plus 40 is tan 60. Tan 60 gives root 3, and we have tan 20 as well as tan 40, and as well as the term tan 20 into tan 40, which is present within this trigonometric function. So we expand this. This is tan 20 plus tan 40 upon 1 minus tan 20 tan 40. So we got this term, and we got partially this term, and this is root 3. So we got this term separately. So now we cross multiply. Tan 20 plus tan 40 is root 3 into 1 minus tan 20 into tan 40. Expanding it, we get tan 20 plus tan 40 is root 3 minus root 3 into tan 20 into tan 40. So we got the complete term. So we shift everything to one side. So we get tan 20 plus tan 40 plus root 3 into tan 20 into tan 40, which is equal to root 3. So the answer is root 3, which is option C. If tan A and tan B are the roots of the equation x square minus ax plus b equals 0, then the value of sin square a plus b is, the options are a square by a square plus 1 minus b the whole square, b a square by a square plus b square, a square by a plus b the whole square, and a square by b square plus a minus 1 minus a the whole square. So it is given that tan A and tan B are roots of equation x square minus ax plus b equals 0. So the coefficient of x, that is a, is the sum of the roots, that is tan A plus tan B, and b is the product of tan A and tan B. Let this be equation 1, let this be equation 2. Now tan of a plus b is tan A plus tan B upon 1 minus tan A tan B. Substituting the values, we get tan A plus B is A upon 1 minus B. Let this be equation 3. So now what we require is sin square A plus B. This can be written in terms of cos 2 A plus B as half into 1 minus cos 2 times A plus B. Now cos 2 times A plus B can be written in terms of tan of A plus B, that is half into 1 minus 1 minus tan square a plus b upon 1 plus tan square a plus b. So we know the value of tan of a plus b. So we substitute the values, we get half into 1 minus a square by 1 minus b square, b the whole square, upon 1 minus 1 plus a square upon 1 minus b the whole square. Simplifying it further, we get half into 1 minus 1 minus b the whole square minus a square upon 1 minus b the whole square plus a square. Further simplifying it, we get half into 2a square upon a square plus 1 minus b the whole square. So 2 gets cancelled, so we are left with a square upon a square plus 1 minus b the whole square, which is option A. So the answer is option A square upon a square plus 1 minus b the whole square. Sine of theta plus alpha equals A and sine of theta plus beta equals B, then cos of 2 times alpha minus beta minus 4ab cos of alpha minus beta is equal to option A 1 minus a square minus b square, B 1 minus 2a square minus 2b square, C 2 plus a square plus b square, D 2 minus a square minus b square. So first we find out this term, that is cos of alpha minus beta. So this is cos of alpha minus beta. This can be written as adding and subtracting theta. We get cos of theta plus alpha minus theta plus beta in a bracket. So we expand it using the formula cos of a plus b. So this is cos of theta plus alpha into cos of theta plus beta plus sine of theta plus alpha. Since it is cos of a minus b, there is a plus sign. So sine of theta plus alpha into sine of theta plus beta. But sine of theta plus alpha is a and sine of theta plus beta is b. Sine of theta plus alpha is a. Therefore, cos of theta plus alpha is root of 1 minus a square. Since sin theta is root of 1 minus cos square theta, and vice versa. Similarly, sine of theta plus beta is b. Therefore, cos of theta plus beta is root of 1 minus b square. So substituting these values in cos of alpha minus beta, we get cos of alpha minus beta equals root of 1 minus a square root of 1 minus b square plus ab. Let this be equation 1. Now we substitute this value in the required expression. So cos of 2 alpha minus beta minus 4ab cos of alpha minus beta. Cos of 2 times alpha minus beta can be written as 2 times cos square of alpha minus beta minus 1, and again minus 4ab cos of alpha minus beta. Now we substitute the values in equation 1. So we get 2 times root of 1 minus a square root of 1 minus b square plus ab the whole square minus 1 minus 4ab into root of 1 minus a square into root of 1 minus b square plus ab. Simplifying it, we get 2 times 1 minus a square 1 minus b square plus a square b square plus 2ab into root of 1 minus a square into root of 1 minus b square minus 4ab into root of 1 minus a square into root of 1 minus b square plus ab minus 1. Again 2 times, further simplifying it, we get 1 minus b square, 2 times 1 minus b square minus a square plus a square b square plus 2a square b square minus 4a square b square minus 1. That is 2 times 1 minus a square minus b square minus 1. That is 2 times 2 minus 2a square minus 2b square minus 1. That is 1 minus 2a square minus 2b square, which is option B, 1 minus 2a square minus 2b square. So the answer is option B. We need to find the value of tan 81 degrees minus tan 63 minus tan 27 plus tan 9. The options are 1, 2, 3 and 4. So we rewrite the expression tan 81 minus tan 63 minus tan 27 plus tan 9. Now tan 81 can be written as tan of 90 minus 9. Tan 63 can be written as tan of 90 minus 27 minus tan 27 plus tan 9. Now tan of 90 minus theta is cot theta. So this is cot of 9 plus tan of 9 minus, taking minus 1 common, this is cot of 27. So cot of 27 plus tan of 27. Now tan theta plus cot theta is equal to 2 cosec 2 theta. So we use this formula. So we get 2 times cosec of 2 into 9 minus 2 times cosec of 2 into 27. That is 2 cosec 18 minus 2 cosec 54. Cosec is 1 upon sine. So we get 2 upon sine 18 minus 2 upon sine 54. 2 upon sine 18. This can be written as 2 upon sine 90 minus 36. Sine of 90 minus theta is cos theta. So we can rewrite this as sine of cos of 36. And this is 2 upon sine 18. This can be written as 2 into 4 by root 5 minus 1 minus 2 upon 2 into 4 by root 5 plus 1. Simplifying it, we get root 5 plus 1 minus root 5 plus 1 divided by root 5 square minus 1 square. That is equal to 8 into, this gets cancelled. So 2 upon 5 minus 1, that is 4. So the answer is D, 4. The question is, we need to evaluate this 8 sin x upon 8 cos x by 2 cos x by 4 cos x by 8. So the options are 8 sin x, cos x and 8 cos x. We rewrite the expression 8 sin x upon 8 cos x by 2 cos x by 4 cos x by 8. We rearrange the terms. So we get 8 sin x upon 8 into cos x upon 8 into cos x upon 4 into cos x upon 2. This is 4 into 2 into sin x upon 8 into cos x upon 8 into cos x by 2 x by 4 cos x by 2. Now this is in the form of 2 sin A cos B, that is sine of 2 sin theta cos theta, that is sine of 2 theta. So we can rewrite this as 4 into sine of x by 4 into cos of x by 4 into cos of x by 2. Again this can be written as 2 into 2 into sine x by 4 into cos x by 4 into cos x by 2. Again this is 2 times sine of x by 2 into cos of x by 2. So this is 2 sine x by 2 cos x by 2, which gives sin x. So the answer is option B, sin x.